This is AP Precalculus Notes for Topic 3.3, Sine and Cosine Function Values. So if you remember from Topic 3.2, we have these equations to find what the cosine of our angle is and sine of our angle, where cosine always gets paired with x, sine is always paired with y, and because we're talking about a circle that might not be a unit circle, it might have a radius of 2 or 3 or something other than 1, we have to divide by that radius. That means if you have a circle that is not a unit circle and you're trying to find the x and the y coordinate of that circle, to solve for this x, you'd multiply both sides by r, meaning that this r comes up over here to the left of cosine of theta, and you have r cosine of theta for the x coordinate and r sine of theta for the y coordinate. So let's go ahead and apply that on example 1. If I know that I have a radius of 4, so r is equal to 4 because this has the point 4 comma 0, then what are the coordinates of these following points? So it tells us also that we have an equilateral triangle. Equilateral meaning that this triangle, all of these interior angles are 60 degrees. So if I know that this angle right here is 60 degrees, and I happen to also know that this line makes 180 degrees, and we're going to assume that it's nice and centered as well, then these two other angles must be 180 minus the 60, or 120. And because there are two angles here, we divide that by 2, and we see, oh, yes, this angle over here is also going to be 60 degrees, and this angle over here is also going to be 60 degrees. And again, 60 degrees is not really what we use in AP Precalculus. We use radians. So technically, we say that this line that has this angle that goes through P has the angle of pi over 3. Pi over 3. I usually draw pi over 3 right here, but really, if I'm being specific, it should be this angle is pi over 3 here. So you'll see these are all pi over 3 for point P, but we're not talking about point P, we're talking about point Q. So if I'm talking about point Q, then I need to go another of these 60 degrees, another of these pi over 3 rotation, and I have 2 of those pi over 3s, and again, 3 of those pi over 3 would be just pi over here. I can label that, but you don't need to know that for this problem. Because I'm going 1/3 of pi, another 1/3 of pi, and then another 1/3 of pi, this point right here is going to be 2/3 of pi. So you can say 2 pi over 3. So the angle that we're really looking for point Q, should be 2 pi over 3. And you'll notice that that gets us down to options C and D because those are both the 2 pi's over 3. By the way, you'll notice that this angle and this angle are always the same because they have to be. Your cosine of that angle and sine of that angle will give you different values unless you're in quadrant 1 with a pi over 4. But that's beside the point. The next thing that I'm looking at, oh, this one has a negative and that one has a positive. In general, yes, you are right. Okay, the x-coordinate should be negative here, right? Because I'm going to the left, therefore the x-coordinate should be negative. So a lot of students are inclined to say, okay, well, it has to be negative. No, it's never going to be negative. This number is always just going to be r. I mean, just look at the formula, right? The formula says it's going to be r cosine of theta. Does it ever say, oh, well, it might be negative r, it might be negative r, depending on what quadrant you are? It's not that specific because cosine itself will give you the negative. If you do cosine of 2 pi over 3, that evaluates as negative 1/2. You don't need an extra negative right here, so it's just going to be option C. But in general, if you have a question like this on the AP Precalculus test, never choose anything that has a negative out front because the cosine or the sine itself will generate that negative value. For example 2, we have coordinates of point P down here. I'm going to go ahead and make a triangle. Usually we always draw a line coming from the x-axis. You could also theoretically draw a line from the y-axis, and it would still work, especially for this problem. But in general, we always draw it from the x-axis. Feel free to be backwards. So I know that the coordinates of point P are 6√2, negative 6√2, which means this length, notice I'm saying length, therefore it's always going to be positive. This length is going to be 6√2. And this length right here, while the coordinates are negative 6√2 because we're going down, the length is positive and it's also 6√2. So I have a triangle and I purposely made it a right triangle so that I can use Pythagorean theorem. So if I go ahead and draw that triangle again, using technology to make it look nice and pretty, please, thank you very much. Okay, this triangle right here has dimensions 6√2 and 6√2, and we can use Pythagorean theorem. I'm going to go ahead and call this point, or this length x for now, and using Pythagorean theorem, okay, you're in the way. Now let's move, I want to go like this. You can move right here. I'm going to say that a squared, the leg squared, plus the other leg squared is equal to the hypotenuse squared. In this case, when I plug in my actual values that I'm talking about here, I get 6 root 2 quantity squared. And it is important that this entire quantity is squared. If you just don't do the parentheses, you assume only the square root of 2 is squared, but this square is going to apply to both to the square root of 2 and to the 6. So be careful here. This is going to be plus the other leg, which is also 6 root 2 quantity squared, and that's going to be equal to the hypotenuse, which we're now calling x squared. So again, I already said it, but I'm going to say it again. This square is going to apply to both of these bases, both the 6, both the root 2. When 6 is squared, it turns into a 36. When the square root of 2 is squared, the square root and the square cancel each other out, leaving behind just a 2. And again, these numbers were being multiplied, so I'm also copying down the multiplication symbol. Copying down the plus symbol, and again, this is the same answer as 36 times 2. And the right side is not going to change. It's still x squared. Okay, 36 times 2 is 72 plus 72, and 72 plus 72 is 144. If you want to undo the square, then you need to square root. So I'm going to square root both sides, and look at that. X is equal to technically plus or minus 12. And why is it plus or minus? Because we don't know what quadrant we're in. We have to choose the correct one. And it doesn't really make sense to have a negative in this context because the radius is a length, and the length should always be a positive. So I can come down here and say the length of our radius is going to be 12. So there was another way to do this. If you have memorized your trig values of special angles, you could have done it another way. If you just happen to know, oh, if I know that this angle down here is 7 pi over 4, and you know, okay, well, sine, I guess you could say, never mind. I don't want to go down that path right now. I'm realizing that may be overly complicated for these notes. I can talk about that at a later time on the worksheet maybe. All right, let's do example 3. So we have the following values. Notice that cosine is always going to be the x value, and sine is always going to be the y value. So I'm literally saying these are all the x's, those are all the y's, and look at what we have. We have a unit circle. Yes, a unit circle means that when we have that formula that says, if you want to find the x coordinate, you need, here, let me write this down because this is important. If you want to find the x coordinate, this is going to be r times cosine of theta. And if you want to find the y coordinate, you need to do r times sine of theta. Well, luckily, guess what r is? R is 1, which means we don't have to worry about it. You literally just do cosine and sine. We can ignore the radius altogether. Love unit circles. Okay, so this is literally asking, what is the x coordinate of the point where you have a 0 angle? Remember, this is a 90-degree angle, this is a 45-degree angle, and this right here, I'm trying to draw the line on top of itself. This line right here is a 0, technically radian angle, not degree. And a 0 radian angle goes through point P, and it's talking about the x coordinate. The x coordinate of point P is just 1. And this is the x coordinate of pi over 2, and it's kind of helpful to know where are these things. You should have them memorized from the last lesson. So this is 0, this is pi over 2, this is pi, and this is 3 pi over 2. And technically, if you come back all the way again, this is 2 pi. So it could be either 0, it could be 2 pi, it could be 4 pi, it could be 6 pi, it could be negative 2 pi, it could be negative 100 pi. Anything that is divisible by 2 pi is this spot right here, and that goes for all of these rotations, right? I don't want to go ahead and review all of 3.2 in this lesson, so let's just jump right in. Cosine of pi over 2 is talking about this pi over 2 right here. Cosine is the x-coordinate. The x-coordinate is 0. I can write down the 0. This is asking for the x-coordinate of pi. Pi is right here. X-coordinate is negative 1. This is asking about the x-coordinate of 3 pi over 2. 3 pi over 2 is down here. The x-coordinate is 0. Over here we have sine of 0, aka the y-coordinate. Again, y and sine go hand in hand. X and cosine go hand in hand. Sine of 0, the y-coordinate of 0. Well, right there is 0. The y-coordinate of pi over 2 is right here. The y-coordinate is 1. For pi lives right here. The y-coordinate is 0. And down over here, 3 pi over 2 lives down here, and the y-coordinate is negative 1. Look how easy that is. All right. You do have to start memorizing these values, by the way. And I'll talk about how to memorize them at the end of the lesson. Let's just jump into the next little bit. So I love this page because it derives where these numbers come from. I've always wondered, well, I hope that you've always wondered with me, why are you getting like root 3 over 2, like root 2 over 2? Where are these numbers coming from? So it comes from just trigonometry. It comes from Pythagorean theorem. So look at this. If you have this angle right here, this angle of pi over 6, then you're asking yourself, what are the x and the y coordinates? Well, we're putting together topic 3.2 and 3.3 at the same time. So you have to, if you haven't mastered topic 3.2, go ahead and do your studying. I highly recommend the blue kit that I've made, or maybe a blue kit that your teacher's made, because it's super fun to memorize where all of these angles are. Pi over 6 is here, pi over 4 is here, pi over 3 is here. You need to know where all of those are first. And now that you know that pi over 6 is here, what are these lengths? What is this length and what is this length? What are the x and y coordinates? That's the question. So to answer that, we always know that we're talking about a unit circle in general. If we're not talking about a unit circle, we can expand the x and y coordinate by multiplying by whatever the radius is. That's what we were talking about back over here by multiplying by the radius. But for now, we're on a unit circle, so ignore the radius, and we're just saying, hey, if we have a 1 here, how do I know how to get down here? If you have your special triangles memorized, you'll remember that there's 2 special triangles that we always use from geometry. One of them is going to be a 30, 60, 90 triangle, and the other one is going to be a 45, 45, 90 triangle. 45, 45, 90. And then if we assume that the radius is always 1, then the hypotenuse is 1, the hypotenuse is 1, and then you can do some cool tricks. I happen to know that if you start right here on a 30, 60, 90 and you go this direction, you have to multiply by 2, and if you go this direction, you multiply by root 3. Same thing for a 45, 45, 90 triangle, assuming that we start right here. To go to the hypotenuse, you have to multiply by the square root of 2. These 3 things you should have memorized from geometry, and if not, I've reviewed them. You're welcome. So if you are trying to get from 1 backwards to x, instead of multiply by 2, we divide by 2. So to go this direction, let me change the color. If I go this direction, I divide by 2, and guess what? 1 divided by 2 is 1/2. Ooh, I can't write the 2. 1/2, which means this length is 1/2. So you might wonder in the notes, like, how did he get 1/2 so fast? It comes from these special tricks. And again, you could also use that special trick to be like, okay, well, what is this x coordinate? The x coordinate is 1/2 times root 3, because we're going the correct direction, and 1/2 times root 3 is, whoa, not back there, is root 3 over 2. And similarly, over here, for the 45, 45, 90, which we will be talking about not now, but in the future, like in 5 minutes, if you want to go from 1 backwards, instead of multiplying by root 2, you divide by root 2. And I'm not going to do that yet. Does he do it here? Okay, maybe he doesn't do it here. I think I've done it in a previous lesson, but let me show you how to do that. If you have 1 divided by the square root of 2, I mean, that is the answer. But the problem is that the denominator is not rationalized. The denominator is irrational. It is a square root. You might ask why that's a problem, and I could talk about the history of how we used to have a giant book that had things with square roots in the top but not in the bottom, and you didn't want to carry around 2 different books, so you had to learn this new method that got rid of the irrational denominator, but that is a story for another time. In general, we always rationalize the denominator. It's a standard practice. Maybe it's an outdated practice, but it is still a useful skill higher levels in math. So let's go ahead and get rid of it. The way that we get rid of the root 2 in the denominator is we multiply by whatever that denominator is, because if we multiply by the square root of 2, watch what happens. The denominator is now square root of 4. That's how square roots get multiplied, by the way. You can just kind of multiply the insides as long as they're both inside the square roots. If I multiply the bottom by root 2, I also have to multiply the top by root 2, because I'm only allowed to multiply by 1 to not change my number. So that means that the top now becomes the square root of 2, because anything times 1 is itself. And then the square root of 4, you'll notice, cancels out. Well, I guess it's a perfect square, so square root of 4 is just 2, and you get root 2 over 2. So if you've ever wondered, where does root 2 over 2 come from? It comes from this special right triangle, which has to rationalize its denominator, getting us root 2 over 2. So another way of showing it is with Pythagorean theorem, and that's exactly what Bryan Passwater does in his notes. He says, hey, if you start with a squared plus b squared is equal to c squared using the Pythagorean theorem, and you plug in the value of 1/2. I don't know where he magically got 1/2. Maybe he remembered half of his triangle. Then you can go ahead and solve to get x squared is equal to 3/4, and then you can do plus or minus root 3 over 4. And again, root 4 is 2, so you just get root 3 on the top, and you get root 3 over 2, which is what we got as well, but we got it a little bit faster. All right, so for point P in quadrant 1, we know it has to be these coordinates. Why does he talk about quadrant 1 here? Because you have 2 possible values. You could be positive or negative of this root 3 over 2. We know we are in the first quadrant where everything is a positive x and a positive y, so both of these numbers have to be positive, thus that number has to be positive. So we can also say these things. We can say that cosine of pi over 6 now is root 3 over 2, and sine of pi over 6 is 1/2, because cosine gives us the x coordinate and sine gives us the y coordinate. So these values you need to start memorizing. All right, so we use the Pythagorean theorem. We're going to be using it again in the future and later in Unit 3. Be ready for that. So let's jump into another example. All right, so the first thing I want to do here is figure out the angle measures of our table. So it already tells me, hey, P is pi over 6. You just did it. Pi over 6. You need to figure out what Q, R, and S are. What are these radian locations. So I happen to know if I went up by pi over 6, using the fact that there's symmetry here, I know that this length right here is, or this angle here is pi, therefore I need to go pi and then backwards pi over 6. So that's essentially saying, what is 1 minus 1/6? Because I can just put pi minus pi over 6. It's the same thing, right? So 1 minus 1/6 is 5/6, therefore this is 5 pi over 6. And then I will relabel these in the table in a sec. I just want to talk about the diagram for now. And then if I go forwards of pi over 6, you have technically 6 pi over 6, which is the same thing as pi. And if I go another pi over 6, you get to 7 pi over 6. Over here for s, we go all the way to 2 pi, which is really the same thing as 12 pi over 6. I made sure that my denominators are all the same. Like denominators make it easy to add and subtract fractions. If I have 12 pi over 6 and I go backwards pi over 6 to go backwards in the clockwise direction, I go minus 1, I get to 11 pi over 6. Those are all of the radian locations that you should have memorized from our previous lesson. So we should say that Q now is a 5 pi over 6, R is going to be a 7 pi over 6, and S is 11 pi over 6. Okay, now it's asking, what are the x and y coordinates of these things? The cool thing here is you can use symmetry. You don't have to have these memorized yet. So I happen to know that this x coordinate and this x coordinate are the same, which means this S has an x coordinate of root 3 over 2. So let me go ahead and label that right now. Root 3 over 2. I don't know what the y coordinate is. I'll leave it blank for now. And I happen to know also that when I reflect over the y-axis, this y coordinate should still be the same. I went to the same height here. So this is 1/2 for point Q for the y coordinate. So it's something comma 1/2. Okay, now we have to figure out something else. We have to figure out like an x coordinate of Q. So what is the x coordinate of Q? Using the fact that there's symmetry here, if this was a positive root 3 over 2, this one over here has to be a negative root 3 over 2. And he did talk about that over here in his notes. He talked about why, I can't remember where he says it. I lost it. I know he talks about it somewhere in his notes. I just kind of ignore it. But it's just like the negative version of that, because you do plus or minus with that Pythagorean theorem. So this is going to be negative root 3 over 2. So it's going to be negative root 3 over 2. And then for R, coming down here, we have the same x coordinate that we just got, which is a negative square root of 3 over 2, comma, and then we need the y coordinate. So the y coordinate is going to be the opposite of whatever the y coordinate was down here using symmetry. So the y coordinate used to be 1/2. Now it is the opposite, which is negative 1/2. And again, the y coordinate is the same down here for point S. Therefore, S is negative 1/2 as well. Use that symmetry to begin finding these calculations, but eventually you have to have these memorized. This is the cosine of 5 pi over 6. This is the sine of 5 pi over 6, right? All right, let's try another. So now, instead of doing all these pi's over 6's, by the way, those always live closest to the x-axis if you're trying to remember those. Then we're going to do the ones that live in the middle. When we're living in the middle, we're doing pi's over 4, or something over 4. So we have pi over 4 here, and then we have 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, and I'm not even going to do the last one because we don't need it. So all of these angles are 3 pi over 4, 5 pi over 4, and 7 pi over 4. Make sure you have these locations on the unit circle memorized. It's going to make your life so much easier. From here, we're going to go ahead and talk about the x and y coordinates. Again, notice that everything is root 2 over 2. There's no two different numbers. Back here, you had either root 3 over 2 or 1/2, and you had to make sure that they're in the correct order. It was always root 3 over 2 for the x coordinate, and it was always 1/2 for the y coordinate. You just have to worry about positive and negative based on the quadrants. Again, that hint that I can come back and say is the quadrant 1 has a positive quadrant, and then I have a negative, positive for the x and y coordinates. Then I have a negative, and then I have a positive, negative for all 4 of these quadrants. Again, it should go quadrant 1, then 2, then 3, then 4, if I'm doing them in order. All right, so coming down here, I have the same numbers. I don't have 2 different numbers, so I can literally, I'm gonna worry about negatives in a second. I'm gonna say it's root 2 over 2, comma, root 2 over 2. I don't know if I'm sure one of them is negative. I just don't know which one yet. So I'm just gonna label root 2 over 2 and root 2 over 2, comma, root 2 over 2. So now I know they're the same numbers. Now I'm going to remind myself, this one was positive, positive. This one's going to be negative for the x-coordinate because I'm over here, but it's still positive for the y-coordinate. So that means for point Q, I should have a negative x-coordinate. I'll put a negative, oh, that negative kind of blended into the fraction, didn't it? I'll put a negative out front like that. And then down here in the third quadrant, it is a negative y and a negative x because I'm going left and I'm going down. So therefore, both of these are going to be negative, negative, and negative. And then for my point S, which is in quadrant 4, my x direction is positive, but my y direction is negative. So my y coordinate is the negative. And we're done. Hooray. All right. And then we go to the divided by 3's. So notice that all of these are divided by 3. I have pi over 3 at this spot. I have 2 pi over 3 at this spot. 3 pi over 3, which we don't care about in this problem. 4 pi over 3 and 5 pi over 3. So coming down here, we can label all of these angle measures. We can say that it was pi over 3 to 2 pi over 3 to 4 pi over 3 to 5 pi over 3. And now we have to find the coordinates. Now we're stuck in that place where we have both a mixture of two different numbers. It's either 1/2 or root 3 over 2. Just similar to the last problem, the y coordinate is either going to be a positive root 3 over 2 or a negative root 3 over 2. That might help you memorize all these. So again, I can kind of do this. Ooh, I can just copy and paste, can't I? I'm going to do 1/2, giving myself room for a negative if I need one, and root 3 over 2. Again, giving myself room in front of it in case I need it. And I can just grab this guy using technology, yoink, paste him, and paste him. And I need to figure out which ones are negative and positive. So again, you could just use that same trick that we used before. Point Q should have a negative x coordinate. Point R should have both negative x and y coordinates. And point S should have a negative y quadrant, or negative y coordinate. There we go. So this diagram is the same diagram that I have posted honestly on my ceiling. When the students are looking up, they're not praying to some sort of deity. They're literally looking at their unit circle to know where their radian locations are and what the x and y coordinates are when we begin, and then I take it down once we are at a certain point. So this, if you need to print out anything, print out this diagram. It is super, super useful. It tells you where the radian locations are, what the x coordinate or the cosine value is, and what the y coordinate, aka the sine value is. Super duper useful. So let's go ahead and see how well you have these things memorized. So sine of 2 pi over 3. So every single time that I'm doing this, this is what's going on in my head. I'm first thinking, where does this thing live? And I'm going to do a little mini diagram. So we'll do a diagram out to the left, I guess. I'll do it like a little unit circle and say 2 pi over 3 lives right there. It's not straight up. It's a little bit to the left. And then I say, okay, sine is talking about the y coordinate. So how much up did I go? I went up a large amount, and I happen to know that a large amount is a root 3 over 2. Again, you should really only have 3 values memorized. You should have the square root of 3 over 2. You should have root 2 over 2 and 1/2. These values, respectively, are large, medium, and small. Those are the only ones that you have to memorize aside from 0 and 1. So I went up a large amount. I didn't go up a medium amount. I didn't go up a small amount. I went up a large amount. And I make sure that the sign is correct on all of these. I went up, therefore it is a positive. Let's move on to part B. Cosine of 5 pi over 4. Again, really quickly, you should memorize where 5 pi over 4 is. If you said it's right down here, you are correct. And this is right in the center, meaning that if it's in the center, it's going to be something with root 2 over 2. The question is it positive or is it negative? Why is it root 2 over 2? Another rationale, just other than it's in the middle, is because it's a medium amount. Cosine is talking about the x coordinate. Did you go left a medium amount, a small amount, or a large amount? Well, that large was way too big, but it went over a medium amount, and I went to the left, meaning this is going to be a negative value. What about part C? 11 pi over 6. Again, you need to memorize, where is this thing? 11 pi over 6 is not to the right, but it's a little bit under that. It's down right here. Okay, cosine is talking about the x coordinate. So how far right did I move? I moved right quite a bit. I moved right a large amount. Therefore, this is going to be a positive large amount, a positive root 3 over 2. And I think it's only 3 columns. It is, okay. Okay, for part D, where does this thing live? So again, unit circle, 7 pi over 4 lives in the middle in the bottom right quadrant, or quadrant 4. Sine is talking about the y coordinate. I'm noticing that I'm moving down. Therefore, my answer is going to be a negative. And the question is, down what? Did you go down a small amount, which is right there, down a medium amount, which it is, or down a large amount? This one went down a medium amount, so this is negative root 2 over 2. For E, 4 pi over 3, know where it is on the unit circle. If I were in my class, I would make everyone use their arm and actually point to it so I know that everyone knows where this is. I usually have them close their eyes so they're not just memorizing it from someone else. If I don't trust them, they would all be facing the wall. I trust them, so I just let them go for it. 4 pi over 3 lives not straight down, but a little bit to the left of that. Cosine is talking about the x-coordinate. X-coordinate means I'm moving a left amount, just a tiny amount. Tiny amount left means I'm going negative because I'm going to the left, not to the right. And tiny amount is 1/2. Part F, where is 7 pi over 6? 7 pi over 6 is a little bit more than 6 pi over 6, and 6 pi over 6 is right here. So it's a little bit more than that, and it's going to go down right here. So if I know that this is where I'm talking about, 7 pi over 6 is satisfied. Sine is the y-coordinate. How much down did we move? I moved down a small amount. Down small amount is negative 1/2. G, cosine of pi. You should all point to pi. Pi is straight out to the left. Cosine is talking about the x-coordinate. X-coordinate out far to the left. This is not one of the small, medium, or large values because it's even bigger than that. This is the largest possible value, which is just the radius, 1. And I moved left 1, therefore I'm doing a negative 1. G, 3 pi over 2. Go ahead and point to it. It's straight down. If it's straight down, we're done, and then we do sine. Sine is the y-coordinate. What is the y-coordinate of straight down? On a unit circle, it's the radius. Down that radius of 1, so negative 1. Cosine of 2 pi over 3. Everyone point to 2 pi over 3. It's not straight up. It's a little bit to the left of that. And cosine is talking about the x-coordinate. How much did you move left? A tiny amount left. So a tiny amount left is negative 1/2. Moving on to J. Everyone point to 5 pi over 3. 5 pi over 3 is not straight down. It's a little bit to the right of that. And then I'm doing cosine, which is the x-coordinate. X-coordinate is to the right a little amount. To the right a little amount is a positive 1/2. And then sine of 0, everyone point to 0. It's that initial angle just out to the right. Sine is talking about the y-coordinate. Well, what is the y-coordinate of not moving up nor down? It is just 0. What is cosine of pi over 2? Everyone point to pi over 2. Pi over 2 is straight up. Cosine is talking about the x-coordinate. X-coordinate is left and right. How much left and right did I move? I did not move. Therefore, the answer is 0. Whew, very, very nice. And then we move on to the worksheet later. So this is the time where I get to tell you, how is it possible for you to memorize all this stuff? Because it's a lot. You have to not only memorize your radian locations, where they live, but you also need to memorize if they're positive or negative. Is it root 2 over 2? Is it root 3 over 2? Is it 1/2? Is it 0? Is it 1? There's an insane amount to memorize. The favorite way that I have found to memorize this is with Blukit. So I've talked about this in my previous video, but I highly, highly recommend it. If you're in your own class, have your teacher do this. If you're doing it by yourself, it still works. The first thing that you need to do is make sure that you have your location of radians memorized. Again, I'll have a link that you can play this. If you host the game as a teacher, there's a bunch of games to play. Currently, I'm recording this in 2025, and Laser Tag just came out and it's in beta, and it is super, super fun. You'll probably have to have a paid account, just like Pirate's Voyage is plus only. Gold Quest and Crypto Hack and Fishing Frenzy are still really great games. And again, if you do not like to play it, or if you're not in a class and you need to play it just by yourself, you're studying by yourself and you need to grind and grind, go ahead and hit the play solo button in the bottom left, and there's still a bunch of games to play. My favorite being Tower Defense 2, but if you are a Monster Brawler or a cafe or a factory sort of person, go for it. By the way, if you do not like to play video games and you just want to grind, factory is the recommended setting for you. It's just grinding over and over again. You do have to click occasionally. So you'll know where your ratings are just by playing this Blukit, and then cosine and sine values are coming from the second Blukit, where again, I'll give you cosine of 0, cosine of pi over 6, all of these values. It's multiple choice, so it's not as good as free response, but it goes fast. It gets those reps in as fast as possible to make sure that you have these memorized. I highly, highly recommend trying to grind on Blukit to have these things memorized. That does conclude the lesson. There's the last page. There's the second to last page. There's the second page, and there's, oh, I guess that was the third page. There's the second page. Oh my God, how many pages were there? There are a lot of pages. There they all are. Thanks for watching. I'll see you guys later.